So we know how to represent a point x comma y. Two, 2. Sometimes one might say, well, if I simply get the points 2, 2, I do not know the direction of this point. Someone else might say, well, I can just change the coordinate system and that is going to give me the direction, because if I find theta, then I'll know what angle I have and which coordinates that point is going to lie on. But in fields such as physics, engineering, we need magnitude as well as direction. A very good example would be force. Force is a vector. Velocity, vector. In terms of physics, we know what force is. Mass times acceleration. In terms of, well, let's see. So you have mass, you put the gravitational constant, and I'm standing here, there is a force that is pulling me downward. Correct? Yes? And suppose I want to know the amount of force that is pulling me downward, then I have direction and I have magnitude. Right? So when it comes to physics, they always would want to have magnitude as well as direction. So 2, 2, instead of simply writing it as 2, 2. Draw a line, and then an arrow. Tail end of the arrow. And that is a vector. I haven't gotten into the notation yet. Now, the interesting thing about a vector entirely different point, yes, but it would have the same magnitude. You could come up with a vector in a different direction, which would correspond to a different point, but it probably has the same magnitude. So, in order to understand vectors, you have to know the unit vector notation. Think of dimensions. If I say x and y, how many dimensions do we have? What? Probably 2. Got lucky. So there are 2 dimensions. So x-axis, y-axis. And 2 dimensions, yes. Each point, say, on this floor, I can represent in terms of a unit vector. So the unit vector in the x direction I, and then you put an arrow on top of it. unit vector in y direction. J. That's an arrow on top. Notation that we use in text and literature will differ slightly if you look at math textbooks. They wouldn't even use the arrow. The R, the J would just be in bold letters. But they will let you know that. So 2 dimensions, I've got I, I've got J. Again, this specific form of notation is useful in physics. No matter what field of physics you get into, this is what they will use. Sometimes engineering. But if you look at statistics, I would see vector in an entirely different way. To me, the direction doesn't matter. All I care about is the point in different dimensions. So I can write 2, 2, 2. Some like square brackets, some like parentheses, I like square. You can even write it that way. I'm not sure what your problem is. Are you with me so far? A point, 2, 2. I'm representing that as a vector. You can either use square brackets or you could use parentheses. Important things to know. Y vector is the unit vector in x direction, J unit vector in y direction. Good? Okay. So that is in 2 dimensions. If I took a point in 3 dimensions, dimension 1, yes. Good. This way. Good. Think of a cube. And I'll pick a point in 3 dimensions. Then the point is in specific directions with respect to the axis that you go to you. If going back to what I used as an example of polar coordinates, projector. Room, the form of a cube. Yes. Let's pick where gate is sitting as the center. Good. With respect to the center, that point is going in that direction. Agreed? However, it is going in that direction, but has the direction defined by I, J, and K. In other words, it tells me, okay, that's the center. This way, based on the I vector, and that way, based on J vector, take a guess what would be the next one. I, J. Okay, so from that center, I walk over, I vector, stand there, go up, K vector. Good. So you have I, J, and K in 3 dimensions. Great. If you want to represent the origin as a vector, how would you write it? In this vector notation, the origin.
This bracket 0, 0.
Very good. Bracket 0, 0. X component. Y component. Or the X value, the Y value. Again, as a statistician, I see it that way. And an engineer, I would see it this way. Good. I'm going to connect the two in the middle. In 3 dimensions, if I want to represent the origin, how would you do it?
Or
Zero.
is it so bracket 0, 0, 0?
Bracket 0, 0, 0. Or parentheses. No one actually made one to the point 0, 0, 0. That is also another acceptable notation for the vector. But these are the common ones that we use. With me so far? 3 dimension, 2 dimension. Since we just have I and J, the unit vector in or along the x direction is 1, 0. X is 1, y is 0. In the j direction, or sorry, y direction, y-axis, unit vector 0, 1. Good. I just want you to take a guess. The unit vector in 3 dimensions naturally would have 3 values because I have x-axis, y-axis, z-axis. So any guesses as to what that would be?
One, 0, 0.
1, 0, 0. What about the j vector? That's along the y dimension. The horizontal. Vertical.
0, 1, 0.
0, 1, 0. Take a guess. Unit vector. This direction. Height.
0, 0, 0.
0, 0, 0. That's the origin.
0, 0, 1.
0, 0, 1. Good. One may ask, well, why do we care about vectors to begin with? Well, this notation used in physics, we need direction, we need magnitude. Easy to visualize. If I give you a point, well, great. It's kind of difficult, but I can still visualize. What about 4 dimensions? What about 10 dimensions? Can you visualize? Can you? That's an easy question. Can you visualize an object in 10 dimensions? No, I certainly can't. But the beauty of man is what the time here in 2 dimensions and 3 dimensions will apply to infinitely many dimensions. You can pick the space. Do you want to use that word? You can pick the dimension of size 200. Whatever that will work here will work in that dimension also. So I can make conclusions without even visualizing. Good. So you may give me a point, a vector in 10 dimensions, and you may ask me, well, what do you think about the direction of that particular vector? I'll probably tell you. It's 8, right? All I'm going to do is extend this idea. With me so far. Why do we call it unit vectors? Any thoughts? What? 1 unit, right? So if you pick x-axis, you have 1 unit. Y-axis or y direction, 1 unit. Vertical, going this way, 1 unit. So we have ones, hence unit vector. There is another reason. I'll get to it a bit. Without getting into too much detail, these 2 unit vectors are called the fundamental or natural basis for xy dimension. I vector j k would form the natural basis for 3D or 3 dimensions. I can come up with natural basis for any dimension. Why? As I said, without getting into too much detail, no matter what point you pick in this 2D space, plane or space, you can represent it by combinations of those 2. Good. No matter what point I pick in 3 dimensions, I can represent it by mixing and matching those. Good. We call it the natural basis because that's the simplest one that you can think of. But there are bases that we can't come up with. Again, too much information. So, what do I mean by getting any point using the basis vectors or the unit vectors? Let's take 2, 2. Good. I'm going to write it in purely vector notation. This is something what people would use in physics. So I'm going to split it up and write it in terms of the natural basis or the confidence basis for 2D. I want you to give me two numbers that will go in there inside the set. So that I get 2, 2. What numbers should go in the circle so that I get the vector 2, 2. So 2, 2. Do you agree? So if I rewrote this 2 times 1, 2, 2 times 0, 0, plus 2 times 0, 0, 2 times 1, 2. Adding. Good. I'm going to get into what I just did. It's called scalar multiplication vector. 2, that is the I vector. Do you agree? So 2 J vector. Yes. Yes. If someone asked me this question, represent the point 2, 2 in vector notation. Any thoughts as to what that would be? Why?
Just 2i plus 2j.
That would be my point 2, 2. Good. Okay, so far. So again, this is something that's heavily used in physics. To me, as a statistician engineer, I only see it this way, the most common. But do we see the connection? Yes, okay. I'll let you try one. But I'll let you try it with it. I want you to represent the point -1, 4, -2. In vector notation, clearly we have 3 dimensions. Do we agree? Okay, good stuff. I'll be doing a disservice to my profession if I just gave you the answer. I'll just show you how we get to the answer to the thing that most of you got it. -1, 4, -2. I can write it that way. Which -1 and the unit vector in the I direction, or unit vector in J direction, -2 in K direction. I can simply write this as -1 times I vector, simply I vector, yes. 4 times J vector, -2 times K vector.